All right, gearing up for that NCEA physics exam? Well, you've come to exactly the right place. In just the next few minutes, we're going to build your ultimate strategy to absolutely conquer kinematics.
You know that feeling, right? You're staring at a question about a ball being thrown or a car accelerating, and poof, your mind just goes totally blank. It's a really common feeling, but I promise you, there is a clear, logical way through every single one of these problems.
And that's exactly what we're going to do here. We're not just going to stare at a bunch of formulas. We are going to build a repeatable, foolproof strategy that you can take straight into that exam room with confidence. So let's just dive right in.
Okay, so here's our game plan. First, we'll break down what kinematics actually is. Then we'll get you your toolkit, the only things you'll ever need. After that, we'll lay out the 5-step master plan, see it in action with a real example, and we'll finish up by learning how to dodge those classic exam traps.
Okay, first things first, let's demystify this whole thing. What even is kinematics? What are we actually talking about here?
So here's the deal for your NCEA Level 2 exam. Kinematics is all about describing how things move, not why they move. We don't care about the forces for now. Just think of it like this. It's the rule book for anything moving in a straight line with a steady, constant acceleration. And that's the key, right? If the acceleration isn't constant, these rules, they just don't apply.
All right, now let's get to the good stuff. Because believe it or not, every single kinematics problem you're ever going to see can be cracked with just one small, really powerful toolkit.
And here they are, the stars of the show. These 5 variables, you'll get to know them as SUVAT, they're the only things you ever need to keep track of. We've got S for displacement, U for the initial velocity, V for the final velocity, A for acceleration, and T for time. That's it. That's the whole cast.
Okay, you ready for this? This slide, this is your secret weapon. These are the 4 equations you'll have on your formula sheet. Now, instead of trying to memorize which one to use and when, which is just a headache, look over at that missing variable column. Every single equation leaves out exactly one of the 5 SUVAT variables. This, right here, is the absolute key to everything.
So how do we actually use that secret weapon? Well, we use it as part of a super simple, repeatable 5-step plan. This isn't about luck or guessing, it's a system, a process that works every single time.
And here's that method right here. It's so simple. Step 1, you scan the problem, you pick a positive direction. Step 2, you list out your SUVAT variables. Step 3, you decode the words in the question to find hidden numbers. Step 4, you use our secret weapon, the missing variable, to pick the right equation. And finally, step 5, you plug in your numbers and solve.
You know, let's zoom in on step 3 for just a second, because it's so important. The exam questions are loaded with what we call implied givens. What's that? Well, it's basically free information. Phrases like starts from rest literally mean your initial velocity u is 0. Dropped, or in free fall, means your acceleration a is 9.8. Learning to spot these little clues, man, it's a huge advantage.
Okay, theory is great and all, but talk is cheap, right? Let's actually prove this plan works with a real NCEA-style problem.
All right, here we go. A steel ball is held 40 centimeters above a table. The ball is released. Calculate the time it takes for the ball to fall. Seems pretty straightforward, yeah? Let's put our master plan to the test.
All right, steps 1 and 2. First, let's just decide that down is our positive direction. Easy. Now we list our variables. Displacement S is positive 0.40 meters. And watch out, first trap right there. 40 centimeters becomes 0.40 meters. The word release tells us our initial velocity, u, is 0. Because it's a fall, we know the acceleration a is gravity, so it's positive 9.8 in our convention. Time t is our unknown, the thing we're trying to find, and we have no idea what the final velocity v is. Okay, so just look at our list there. Which of those 5 SUVAT variables is completely off the radar? We don't have it, and the question isn't asking for it. That's it. The completely missing variable is v, the final velocity. So all we have to do now is go back to our toolkit and pick the one and only equation that doesn't have v in it. And that equation is s equals ut plus half at squared. See how easy that is? Zero guesswork. The problem tells you which formula to use. And boom, step 5, the home stretch. We just plug in the numbers we know, do a little bit of algebra, and there it is. The time it takes for the ball to fall is 0.286 seconds.
The 5-step plan just walked us straight to the right answer. Perfect.
Okay, so now you've got the method down. Let's give you that expert edge. We're going to look at the most common traps that catch people out in the exam so that you can just sidestep them completely.
First up, and this is a big one, you have to know the difference between displacement and distance. Displacement, that's the S in our equations, it's a vector. That just means direction matters, so it can be positive or negative. Distance, on the other hand, is a scalar. It's just about how much ground you covered. It's always positive. Getting these two mixed up, it happens all the time, so watch out for it.
And here are 3 more classic traps to dodge. Number 1, unit conversion. Always, always, always convert kilometers per hour to meters per second. Just divide by 3.6, don't forget. Number 2, your sign conventions have to be consistent. If you decide up is positive, then gravity, which pulls down, has to be negative 9.8. And number 3, the word deceleration. It just means slowing down. That's it. It does not automatically mean your acceleration is negative. That depends entirely on your sign convention.
All right, so let's bring it all home. If you walk away with anything today, make it these 3 things. First, kinematics is only for constant acceleration, period. Second, that secret weapon? Find the missing variable. It will tell you exactly which equation to use. And third, use that 5-step master plan on every single problem. It's your safety net. It'll guide you to the answer.
So there you have it. You've got a complete system now. You have the tools, you have the strategy, and you know the traps to avoid. The only thing left to do is to actually use it. So, what problem are you going to go solve first?